Okay, so let's work on 1, 2, and 3. Number 1 says calculate the degrees of unsaturation in each of the following formulas and then draw as many structures as you can. However, I have not mastered drawing the structures yet, so I'm just going to skip that part for now. I may come back to it later and work it again, but I'm not the best at that yet, so I'm not going to teach you something I don't know. So let's just work on how many degrees of unsaturation there are. Well, if we have an unsaturated C4H8, then we can figure out our saturated with the formula that we know, which is CnH2n plus 2. And so in this case, our N is 4 because of the C4. And so we can say C4H4 times 2 plus 2 gives us C4H8 plus 2 is 10. And we can subtract C4H8 from C4H10. That gives us H2. And remember that we're measuring our degrees of unsaturation in pairs of H's. So you can say this is 1 degree of unsaturation, or you can divide by 2 to get 1. So this one is 1. Remembering that our saturated structure looks like this. We have 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. That's 3. 3, 6, 7, 8, 9, 10. So this is our saturated, which is here. And that an unsaturated could be this. It could be a ring. And it could be a couple other things. Remembering that we calculate our IHD from rings, or number of rings, plus pi bonds. That gives us our IHD. So if we have no rings, that's 0 plus 1 pi bond, that's 1. Then we get an IDH of 1. Here we have a ring and no double bonds, so we get 1 plus 0 equals 1. And those are two valid structures, but I do not. And then, you can count a pi bond as more than one pi bond. So a triple bond, that's 1, 2, 3, 4. But we have to remember that we need to have 8 total hydrogens to our 4 carbons. And I don't believe this one does. This one is 1, 2, 3, 1, 2, 3. It's got 6. This is 1, 2, 3, 4. So that's doesn't have any hydrogens, and neither does the other one. So this isn't a valid structure, but just to show that we can count these 2 bonds as for our IDH. This wouldn't make any sense anyway, though, because IDH here would equal 2. So it's a good way to check your work and make sure that you're drawing legitimate structures is to draw something you think it could be. So we could say it could be this, right? And then going, okay, 1, 2, 3, 4 carbons, that's right. We have 1 bond, so the IDH is 1, so that looks pretty good. You could draw it over here instead. That's the same molecule, basically. So I think it's the same structure. You could draw it like this. I think 1, 2, 3, yeah. So this one's got 1, 2, 3, 4, 5, 6, 7, 8. So that's a valid structure. You can look in the answer key and see. Let me erase all my scribbles. You can see that they cut off here. There are 1, 2, 3, 4, 5 valid structures. So you can even have this triangle with a methyl group on it. That's valid. IDH there is 1 because you have 1 ring and no pi bonds. So I think if I were to go back here and draw a triangle, I'd have them all. The methyl group. That would be 1, 2, 3, 4, 5, 6, 7, 8. Remember, this one's got 2 on each corner. This one's got 2 here. I'm sorry, 1 here, 3 here, 1 here, and 3 here. This one's got 3 here, 1 here, 2 here, 1 here, 2 here. 2, 4, 5, 6, 7, 8. So these are the ones that I would draw for this compound. It's a little bit confusing and it's a little bit difficult, and until I figure out a way to make it really easy, we'll do this one, but I won't do the next ones. Okay, so let's work on the next one just to get the degrees of saturation, and then we'll move on to the next questions. All right, so degrees of unsaturation. Here we've got the same C4. So C4H6 now. We just said that C4 gave us H10 when it's saturated. So we can go ahead and subtract that 6, giving us H4. Divide that H4 by 2. That gives us 2 degrees of unsaturation. So number B, or letter B, is 2 degrees of unsaturation. And for C, we get C3H4, where we've got C3H3 times 2 plus 2. That's 6 plus 2 is 8. So we have C3H8 minus what we have, C3H4. Again, we've got H4 divided by 2 gives us 2. So these are both 2. So this is just mathing as much as, just simple mathing. Moving on to the next one, 7.2. We have calculate the degrees of unsaturation in each of the following formulas. And now we're getting into having those extra atoms that do something to our IDH. And here are the rules right up here. If you have halogens, you add. If you have oxygens, you ignore. And if you have nitrogens, you subtract. So for A, we have C6H5N. Nitrogen, we subtract. So that means we really have C6H4. And they want to know what the degrees of saturation are. So we would say a fully saturated C6 would be H2 times 6 plus 2 would give us C6H2, that's 12, 14. And so then we would subtract H4 from it, and that would give us H10. We'll divide that by 2. That gives us 5 degrees. We could do B, C6H5NO2. Remembering that we subtract this N, but we don't really care. We ignore the O. So we'll ignore the O. The 2 O's, we'll ignore both O's. And we just said that C6 was C6H14, so we still have C6H14. We pretty much have exactly the same thing we had before. So we still have C6H4 because we're going to subtract that nitrogen. Gives us H4. And now we have H10 again, divided by 2, gives us 5 degrees of unsaturation. Okay, moving back over here, we've got C. C has a halogen in it, a couple halogens. Remember that we add the halogens to our hydrogens, so we have C8H9 chlorine 3. So we're going to add 3 to the hydrogen. That gives us C8H12Cl3, which we're going to just take the Cl off. We've added it to the hydrogen. And now we're going to look at our saturated, which is going to be C8H8 times 2 plus 2. And then we know that that is going to give us CH, that's 16 plus 2, that's 18. We'll subtract our H12 from it, giving us 6. H6 divided by 2 gives us 3 degrees of unsaturation. so that's 3. If we look at D, we've got C9H16, bromine 2. We are dealing with a halogen, which means we're going to add 2 to the hydrogen count and get rid of that one. It's going to give us H18. So now we know that our C9, H9 times 2 plus 2 gives us C9, H18 plus 2 is 20. We can subtract our H18 from it, leaving us with 2 hydrogens. Divide 2 by 2, you get 1. This is 1 degree of unsaturation. Let's look at E. E is C10, H12, N2O3. We know we can ignore the oxygen. We can subtract our 2 nitrogens and then get rid of it. That's going to give us C10, H10. Our saturated C10 is going to be 10 times 2 plus 2. That's C10H22. And then we can subtract our H10 from over here, there. That's going to give us C10H, what's that, 12? Yeah. Divide this H12 by 2, getting ahead of myself, and that gives us 6. That's 6 degrees of unsaturation. Okay, let's go on to the last one, F. F is saying that we have C20, H32, Cl(N). Remembering that if we have a halogen and a nitrogen, that we're adding, that we're subtracting nitrogen and we are adding chlorine, so we would do plus 1 minus 1, and those just cancel out. So we are left with C20, H32. So if you see something sort of like this, you can go, oh, those cancel, and just scribble them out, and you're left with the correct formula. We know that a saturated C20 is going to give us 20 times 2 plus 2, which would give us C20H42. And now we can subtract C20H32 from that. We get 10. 10 divided by 2 is 5. And so those are your degrees of unsaturation for F. That's 5. All right, let's look at 7.3. It says diazepam is marketed as an anti-anxiety medication under the name Valium. It has 3 rings, so that's important. I like to underline things that are important or highlight them. It has 3 rings, 8 double bonds, and the formula is this. We don't know the hydrogen though. How many hydrogens does it have? And they want us not to count hydrogens in the structure. They do give us the structure down here, but I'm really not going to use it much because I'm going to work backwards. So in the problems before, we used the formula to figure out the degrees of unsaturation. But now, and we had the number of hydrogens there, but now we're going to work backwards and fill in how many hydrogens we have based off of what our IHD is. And so we can figure out what the IHD is by saying we have C16, and we know that C16H saturated would be 16 times 2 plus 2, and that would give us C16. H32 plus 2 would be 34. And so this would be our saturated carbon. But we also know that IHD is calculated by number of rings plus number of pi bonds. So we can say we have 3 rings and we have 8 pi bonds. which gives us 11. And that's our IHD. So we know that there's 11 degrees of unsaturation, and sort of like what we did before, where we said if we know that we have, let's just look at A. We have C6, or let's just look at A on the first one. If we have C4H8, and we know that our C4H10 is going to be our saturated one, we subtracted, and then we divided by 2. We're going to kind of move in a backwards fashion, and that gave us 1, right? So we're going to say, okay, our IHD is 11, which means that multiplied by 2 would give us how many hydrogens there are. So there would be 22 hydrogens, right? So that would be in our unsaturated ring. So now we can say C16H34 minus C16H22. This is our unsaturated. This is what our IHD is telling us it is. Gives us 2, 1, 12 hydrogen. 12 hydrogens. Well, we've already multiplied by 2, so we're good there. So now we have 12. That's how many hydrogens I think there are. But I have to go back and look at what else is in my compound. So the total formula is C16H question mark Cl N2O. And so I've got an oxygen, which I know I can just kind of ignore, but I also have a halogen and a nitrogen, 2 nitrogens really. And I know that I usually would add chlorine and subtract the nitrogen. And so I know that they're going to cancel each other out in some way. So the chlorine will be canceled out by the nitrogen, and one of the nitrogens will be canceled out by the chlorine. So we'll have 1 nitrogen left. Now, when we're moving in the opposite direction, we have to use the opposite operation to get where we want to go. And so since we would normally subtract nitrogen, we're going to add it instead. So we're going to add nitrogen here, and that gives us 13. And so this is the number for our H, 13. Cl N2O should be our proper formula. This one is like a little bit strange because it takes a lot of work to get to your final answer. I don't think he would ask us something like this on an exam. I think this would be kind of a weird question to ask. But just understand that you find the IHD because they tell you there's 3 rings and 8 double bonds. And then know that that's the number of degrees of separation, which means that times 2 would give you the number of hydrogens that are missing from the molecule. And then you would subtract the saturated from what we think the unsaturated is. That gives us how many actual hydrogens we're missing. And then we add in our other elements or subtract them. We just do the opposite of what the sign is. So if it's adding, we subtract. If it's subtracting, we add. And that's how we end up with 13. It's a little bit confusing, but I think if you work it a couple of times and just like understand what's happening, you'll be able to see it better.